Yeah, my name is Kai. I'm the technical co-founder of a company called Kimata. So we had the luxury of starting a new company about a year ago, and I got the chance to to build an application from scratch the way I always wanted to build an application. One of those things involved using a graph database as the main data store. And I'll share with you some things we ran into and like how we have been thinking about building out these graphs and how we use Neo4j to to model everything that's going on uh, in our application. So I'll show you that. So I was going to talk a little bit about what Kimata does, share the architecture, take a look at the graphs and how we have implemented it, and just share a bit about what we've learned and what we got out of it. So Kimata, we're in the procurement space. It's a SaaS application, very heavy on AI. We basically create agents for all corporate stakeholders that are involved in a buying process. And then we support the people in the organization that want to buy something, typically software, which is where most of the complexity in buying software is pretty high. So they go through all kinds of work, they do searches, they write all kinds of documents, the business requirements documents, they need to calculate the ROI for it, they make shortlists, they talk with vendors, they go through architecture reviews, all kinds of things that happen typically in documents and spreadsheets, and email over Slack, whatever it is. And we want to support the people where they are in this work. So we don't want to force them to come to our application, and we want to just help them do the right things. So we've got agents in there that represent the procurement team, that represent the security team, the privacy team, compliance team, legal team, whatever it is, that can support these regular users throughout their work. So again, we're trying to make this very human-centric, very fluid. And we built this engine, we call it the flex flow engine. It's not a rigid workflow, it's a very flexible way of working. And then we integrate with more traditional enterprise software systems for financial planning and asset management and stuff. And we once people have made decisions in our application, we then trigger, for example, a creation of a purchase order or so in an ERP system or whatever it is. So it's a very human-centric, flexible way of working. So a big part of our whole philosophy is to meet people where they are. If people spend time in Slack and on Google Drive, then we read the documents there, we interact with people on Slack, or if they use Teams and SharePoint, we can do that. So we try to meet the users in the tools that they normally use. So this kind of dictated our architecture a lot, that we've built the application in a very event-centric fashion. That's something I've always liked. I think events are a very natural way of modeling what's happening in the world. So we have listeners that listen in to Drive or SharePoint, to Slack or Teams, to email, and just understand what's happening there. And then, of course, we have our own UI that feeds the listeners as well. And our own UI is also has a lot of chat in it, and then dashboards and visualizations of what's happening in the chat. So a lot of it, what we do is we have to interpret the intent of what the user wants and then act on that. We have a large set of agents in our platform, both representing users, as I said, the corporate stakeholders. Every user gets an agent when they log into the application for the first time. And we have a set of system agents that just perform work that's predefined in our system. Then this all runs on GCP. We connect out to various SaaS applications. And almost all of our logic lives in LLMs. So our application layer, in a way, is relatively thin. It's very event-centric, as I said, and we drive everything that's happening through messages. But super important for us is the data that we build. So we have built several graphs, and I go into those in more detail. That's our main data stores. We, of course, have a vector database to embed documents and stuff, configuration that lives in a relational database. We use a lot of documents also to configure the application. But the graphs really are what make the big difference here. And I would argue today almost anybody can build any application by cleverly using LLMs. But the context becomes the most important thing. The context becomes what truly can differentiate an application. So if you can build valuable context, you have a valuable application. Then, of course, you have to be clever in how you use your context. But I'm convinced that the big differentiator nowadays is context. And for us, the context comes in two different flavors. We have what we call an internal tenant-specific, we call this thing the context graph, where we capture everything that happens in the company as they either work in our application or just upload documents and they chat in channels where we are listening in. We grab all the documents we need, we make embeddings out of them. This is all part of this tenant-specific internal graph. And this thing builds over time. So everything the customer does gets recorded in this internal tenant-specific graph. And then we have what we think of as an external tenant-independent graph that we have built over time that basically models the whole software market. We have something like 1,700 categories of software that we track, a dozen or so vendors and products in each category. This thing is constantly being updated, and it becomes the source of truth for a lot of the intelligence as we guide people through the procurement process. So we've got these two graphs, and they're very different by their nature. This internal graph is tenant-specific, has very complex relationships between the entities. It gets updated super frequently. As soon as you chat with somebody, as soon as you create a document or even just access a document, we update this graph. So it's a high-frequency update. The traverse is very unpredictable. I think we've probably traversed it starting from any node, ending at any node. What the user wants to know, again, we interpret the intent of the user, and what they need to know really dictates how we use this. And the graph branches out a lot. It calls into our external graph, it calls into our vector database, it calls into all kinds of other places, because it's really what's holding everything together. While the external graph is very different, we only have one instance of it. It has very simple relationships. Some of the nodes get updated with very low frequency, like new categories. Maybe we add once a quarter or so. Some nodes with very high frequency, and it's a very predictable traverse. Typically, if you're in one node, we pretty much can tell what you're going to do next. So, and the graph is very self-contained. Other graphs point to this, but this one doesn't point out. So, for us, it was a big question: how do we model this in the databases? And the first thing we started with was to isolate each tenant into its own database, and then use Fabric to try to query across these. So we've got this external global tenant with the external graph, and then we have each customer gets their own instance, or each tenant gets their own instance of a database for the context graph. This was kind of a good start. It was nice to have it all isolated nicely, but the overhead became just too much. Updating things became a little tricky. We have to script everything and run big jobs across all tenants. So we skipped this idea, or we abandoned it rather. We actually started like this, and we abandoned it and went for a tenant scoped solution where we have just one database for all tenants for the internal graph, and then one database for the tenant-independent graph. And then we use constraints to make sure that all the operations that happen, that the application performs on the database, always are scoped exactly to one tenant. And this makes it much easier, makes the whole database administration easier. It forced us to do a little bit of work for the logic to isolate these tenants. We built some or used some triggers to make sure that cross-tenant traversing is not possible. And all our queries always get parameterized with the tenant ID to make things tenant specific. So now we need to connect these tenants to the global database. That's been relatively straightforward to do. So because everything goes just one way, so everything is from a tenant to the global store. So that made it relatively easy. We built some triggers again to enforce that it's a one-way thing. So this we have in place now. Then, of course, I realized we may want to traverse the other way to do some statistics and investigate some of the tenant-specific graphs, but a lot of it is just to collect statistics. So we have created a service user, a statistics service user, that now is allowed to go from the global instance into all the different tenants, so it can traverse the other way, but only this one user, no normal user can do that. And then now that we are putting some more sensitive customers onto this whole application, people have started asking about single tenancy. So one thing we are considering is to use some kind of selective isolation here, that certain customers, maybe for an extra fee, could get their own tenants or their own databases, have their tenant in a separate database. And then we're back to using Fabric to try to hold all of this together again if we need to traverse across multiple tenants. So we'll see if we're going to do this. We'll see how much interest there is from customers for these highly isolated things, but it's something at least we know, or we believe we know, that we can do this going forward. So that's how we use graphs in our SaaS application. This is working really well for us. So this proprietary market graph where we build every day, we're out trolling on the internet, finding things. This is a big IP moat. We've built this big graph that really models the whole software market, so we can give really meaningful advice to our users. And the customer context graph makes us sticky, because like once you have all your data in here and we know the whole history of everything you've done around buying and using software, that makes our application pretty sticky. It makes it very valuable. It makes it smarter over time. And these graphs have really helped us to make fewer LLM calls and get better results from the LLM calls we make. Often we can find the answer to a question the user has directly from our graphs, and we just use the LLMs to format the answer. We don't need the LLMs to actually find the answer. So gives highly repeatable results. And when we make LLM calls, we get great context out of our graphs here. So that's what we've done. That's how we thought about modeling the world. And I've always found it a very natural way to model the world in graphs. I'm very happy we got this chance to start it from the very beginning, using the knowledge graphs as the primary data store.